Hey everybody. Before we get back to talking about using TensorFlow and Scala, let's work through setting up a basic Scala project. In this case, we're going to be using SBT, my build system of choice. We're going to talk about how we load that project into Ammonite. In particular, we're going to load it into almond.sh, which is a Jupyter Lab kernel based off of Ammonite, as well as we're going to load it into the Ammonite shell on the command line. And discuss how this sets up a pretty nice environment where we can write most of our code in an IDE of choice, get all the niceties there, but still be able to load it nicely into Ammonite to do interactive exploration. I'm using a slightly different setup than last time, so hopefully there isn't too many problems. I've already noticed some screen noise that crops in on occasion. We'll just try to avoid that or edit it out. So here we are. Empty folder. I'm just calling it starter for now. You're welcome to call it whatever. And to set up SBT, first thing we need is a build.sbt. Note that we don't actually need to create a build.sbt to get started. We could just start with SBT and compile code, but we want to be able to publish it, and we want to publish it with a particular name. Go ahead and create a build.sbt here. And the first thing I like to do in my build.sbt is establish the version of Scala that I'm going to be working with to make sure it's fixed for this project. And in this case, I want to work with the latest version of 2.13. Scala 3 is coming out, and it's getting really close. And I'll update this guide to Scala 3 once it is actually out. For my SBT projects, I like to explicitly define the root project. If you don't do this lazy val root, it's going to take all these settings here and stick them in the root anyways, but I like doing it this way. The three properties I want to set for our basic project here is the name of our project. I have it in the folder named starter, and I'm going to keep that same name. It's good to keep these consistent. We also want to set the organization. I use the organization name local if I don't want to distribute this publicly yet. I think local is a pretty good tag for like, oh no, keep this local, don't use it. But if you're working for a company, like if I'm working for Doghead Bone, I'd use, the domain name for that. But in this case, we're just going to call it local. And finally, we want to set the version. The snapshot part of this version is important. This means that whenever something references this dependency, such as ammonite or another SBT build, it's always going to check for a new version. It's not going to use whatever version it's already acquired. It's going to check for a new build of that version. Since we're doing this development, we're going to be rebuilding this a lot. We want to stick with snapshot. Okay, with this little build.sbt, we have almost everything fixed. We're working with SBT in a stable build environment. I'm going to go ahead and start SBT. And you can see that it says, welcome to SBT 1.4.1. That is the version of SBT that this launcher, the SBT launcher, is associated with. I actually want to use a newer version of SBT. So I'm going to go ahead and shut this down and go back to our build.sbt. To request a newer version of SBT, we will edit this build.properties file. Notice that as soon as I started SBT, it created a project folder and a build.properties. We're going to go ahead and open this build.properties. Note it defaulted it to the current version of SBT associated with the launcher. I'm going to change this to a new version of SBT 1.4.9. And now SBT 1.4.1 launcher is starting up, but the first thing it's going to do is fetch 1.4.9. You notice now we're in 1.4.9. So with this, we have a very basic SBT project set up. In the future, if we were to load in this project, it would always use this version of Scala and also that version of SBT. So we know this project build is going to be stable in the future. We don't have to worry about versions changing underneath us of either our build tool or our language. Of course, we want some actual code in here to build and that we want to load later into Ammonite or almond.sh. And to do so, we want to create our folder for source code. Having our main source or main module under source/main/Scala, well, that's pretty standard. And then I picked the next folder to be the same name of our organization. Again, I'm using local for the organization right now. And then the name of our package starter. We can go ahead and create a main under here. Okay. Now we have a very basic main. It will fail immediately because we say we haven't implemented. That's what this triple question mark means. I'm going to go ahead and start the language server for this, and this is going to use Emacs Metals, which is Scala Metals Emacs server. So we see new SBT workplace. Would you like to import the build? Yes, we would like to import the build. We'll wait a bit as it indexes. All right, there we go. Get too much value out of that, but let's go ahead and do something like so. So it compiles nicely, and we see it did compile. We go back to our SBT shell. Oh, interesting stuff, huh? Let's talk about what happened here. New client connected, network 1. This is actually expected. I have my Emacs configured to use SBT as the build server. There's also a Bloop build server. They both work fairly well in my experience, but I like to use SBT these days. I think it's starting to work quite well, and it saves some resources on my machine to keep SBT as the single build server that's going on. But we also see some other stuff here. New files, metals.sbt. This is added by the LSP metals, this little SBT file. We'll go ahead and check out what that is. And you can see this is auto-generated. All it's adding is a SBT plugin, SBT metals. And this will be kept up to date by your LSP layer. Apply these changes by running reload. We want to do that. So we'll go ahead and hit reload. And then we're going to go back to our source code here. Not much has changed. It can still do our type inference and everything like that. Pretty happy there. And if we want to run our little main here, we just do run. It's going to compile it, and then it's going to run it. Hello, internets, as expected. So there's some very basic code here. For interactive exploration, we probably wouldn't be running the main in Ammonite. I'll show you how that works. It works just fine, but we probably have some other objects or packages in here that we would be exploring under Ammonite. Just to show what that would be like, I'm just going to add some constant values here. I'll just do X and Y, just so we can have something that isn't a function to reference in Ammonite. Again, we'll run it, no thing. But you'll notice it didn't compile it. How did that work out? Oh, that is because as soon as I saved here, LSP requested SBT to compile this. And if we were watching this, we would see notification that it did compile everything. So by the time I actually got back to here to hit run, it was already compiled. So it's good to go. Okay, so we have a very basic project here with just minimal amounts of code. Now I want to load it into almond.sh, which is loading it into Ammonite, and show how we would be able to do interactive exploration of our package there. So let's go check out the Almond documentation. And yeah, here's a nice explanation of it. Again, it's built off of Ammonite, which is a very nice shell, and we'll show using that directly. Sorry about the odd noise with my screen capture. I don't really actually know what's going on there. But we'll start with the install documentation. Java, blah, blah. You can check if a JVM is installed by running that. Okay, let's go ahead and give that a shot. I already know Java's installed, but let's show what it looks like. Because I want to touch over, you see how I'm doing OpenJDK 11 here? And if we go back here, if you don't have an JVM yet, we recommend installing Adopt OpenJDK version 8. I don't recommend version 8. It'll work fine. I think it's a good JDK to use. It's long-term support and everything. I recommend the latest Adopt OpenJDK LTS that supports Scala nicely, and that is OpenJDK 11. And you notice that's the default one selected if we go to download Adopt OpenJDK. I already have that installed, so no need to worry there. It also recommends using Corsair to install. I already have Corsair installed. I think it's a pretty good utility for not just installing Almond, but I also use that to install Metals, the language server for Scala. So we already have this, and we're just interested in this command right here. Corsair launch fork almond install. I've already installed Almond, so this will just report that we already have it installed. If we didn't have it installed, it would show some dependency resolution progress, stuff like that. But we're good to go on this machine. The next thing I want to install is, of course, Jupyter. And we'll go to our Jupyter Lab documentation, and we'll go to installation. There's a few options here: conda, pip, pipenv. I think Python dependencies are kind of a mess. In the JVM Scala universe, we can have multiple versions of the same library installed concurrently, and projects can reference the particular version that they need. In Python, that does not seem to be the case. There seems to be only for one environment a single version of a library. Kind of a pain, but we're going to go with the pip one. I don't do enough Python for that to really matter. But in my case, I do know I'm using Python 3, so I actually want to do pip 3. Again, I already have it installed. You'll probably see a lot more output than this, but in the end, you should see it succeed. So we have our Jupyter Lab installed, and we have our Almond shell installed. Let's try loading Jupyter Lab. Let's see what the docs say about that. Starting Jupyter Lab. Start Jupyter Lab using Jupyter Lab. Okay, that seems really easy. Let's give it a shot. Alright, you should see some output like this, and it should have opened a web browser page to localhost, which will look like this. And this is what we expect. We see our project here with our source code and our build.sbt, and we see the option to start a Python or Scala notebook. I don't care about Python, so we're going to go ahead and try starting a Scala notebook. Cool. Created an untitled IPython file in there, and now we want to load our project library into our Almond shell, which is loading it into an ammonite session. Ammonite has some pretty good documentation on all this type of stuff, but I'm just going to go ahead to immediately. Remember, we are using the organization local and the project name starter. And what this does, this little, if we can zoom it up a bit, $ivy, it's a meta import or magic import of ammonite, which is saying resolve via ivy this library. And we know our organization is local, our project is starter, and our version is that. Now this is going to fail. I know it's going to fail because I haven't published this library yet. What we want to do is, from our SBT shell here, we want to do publish local. And we see published starter 2.13, blah, blah, blah. Exactly how we expect. In fact, I'm going to do slightly fancier here, where I'm going to say tilde publish local. And this is going to wait for any file changes and publish it whenever our source code changes. So if we go back to our Almond shell, I want to load the latest version. What I'm going to do is I'm going to hit this button, restart the kernel, and rerun the whole notebook. I'm going to re-execute this magic import, and we can import our main, using Shift Enter to execute this line and create another line. And then we can actually even run our main. Again, Shift Enter, and we see Hello Internet. And we can reference our variables that we have in main, and we can see it works as expected. There is limited autocomplete within Ammonite. You can see in this case it works just fine. I find that the LSP completion, of course, works a lot better. Let's go back to our source code here, and I'm like, wow. Let's change this to Hello Ammonite fans. Again, hit save, already compiled. We already see that it's published it. And if we go back to our notebook here, again, we can hit restart kernel, hit restart. It does exactly as described. When it restarts it, loads this. Hey, look at that. We already have our change good to go in here. Excellent. And this is really the basis of interactive exploration I use for a lot of projects. I do the bulk of my development in an IDE, and then I always have this type of notebook up and running so I can quickly explore with all the benefits of Jupyter Lab, including stuff like graphene, image display, all sorts of fun stuff that we'll talk about later. So this is nice for a web browser, but if you're like me, you also want command line utility of this. So let's go back to our command line. Like I mentioned, this Jupyter Lab, almond.sh, is based off of Ammonite. We can, of course, run Ammonite ourselves. If you don't have Ammonite installed, there's instructions on the Ammonite IO documentation page. And you see we've loaded up Ammonite. Again, that Ivy thing, that was an Ammonite specific aspect. And we can do the same within the Ammonite shell. And again, and we can see that it works as expected. Unlike almond.sh, there's no convenient way to just rerun everything the Ammonite shell that we've done so far, at least not that I know of. If you know of a way, let me know in the comments down below. But this is a pretty useful setup for me. I get command line exploration if I want it via the nice Ammonite supershell. I also get notebook exploration if I want it, but I still get all my fanciness of an IDE, which I quite like, with all this fun autocomplete and type inference and other utilities that LSP provides or IntelliJ provides. And that's our full project setup. Nice starter project and how we load that into Ammonite tools for interactive exploration. If you have any questions, let me know in the comments down below, and I will see you guys next time.